start with our discussion. And kindly prepare already your calculator because I will be asking for some participation later sa ating competition or at least you have initial practice with our competition. Say present when your username Acebeda,
Sir, present.
Adalia,
Present po, sir. Present
Paprika,
po.
Present po.
Balogo, Bartinas,
Present po.
Barlaan,
Sir, present po.
Bartolome, Bautista, Belo,
Present po.
Bonayon Jr., Buenape,
Present po, sir. Bonayon.
acknowledge, Buenape,
Sir, present po.
Buena Cobra, Campbell,
Present po, sir.
Karinan, Sekenya,
Present po, sir.
Condesa,
Present po, sir.
Cordeta,
Present po.
Cuevas, De Borde,
Present po.
De La Cruz,
Present po.
De Malata,
Present po.
Enriquez,
Present po.
Pamudulan,
Sir, present. Present po.
Fernandez,
Present po.
Galit,
Present po.
Gante, Garcia,
Present po.
Gonzales, Gemino,
Present po.
Humawid,
Present po.
Libres,
Present po.
Liagas,
Po.
Lorenzo,
Present po.
Lotibio,
Present po.
Manlangit, Marcos, Mateo, Nakar,
Present po.
Nicolas,
Present po.
Oralio,
Present, sir.
Panikan,
Present po.
Roluna,
Present po.
Saavedra, Sumampong, Tobias,
Present po.
Tusi,
Present po.
Villa Carrillo. Okay, another roll call. No? Say present when you hear your surname. Balogo. I think you are chat box. Balogo, are you here? Bartolome. Okay. Senador Emergency. Bartolome is present. Oh, and Balogo Bautista. Buena Obra. Karinan.
Present, sir.
Cuevas. Gante. Gonzales. Marcos. Mateo. Saavedra. And Sumampong. Okay, so let's before our discussion, if you're not aware with our calendar, the school calendar, next week will be Holy Week, no? And sa official announcement ng Fatima, it is a academic break, no? Pero basically Holy Week yan, no? Within the week next week. But merong extension ng April 10. Actually, ito ay naging extension dahil parang na-offset yung araw ng kagitingan, no? April 10. Okay? So meaning, ang week 11 natin or the last week prior the midterm examination will be on April 11 to 13. Kasi ang ating midterm examination will start on April 14 onwards. So April 14, 15, that's Friday, Saturday, then 17, 18, 19. Yan yung continuation the other week. Or yes, no. Now, let me show you the schedule sent to me, just for your information, for the schedule of midterm examination. But just be standby kung sakaling mo may changes. Ipopost naman to sa Canvas. No? Are you seeing this one already? Yung schedule sa Excel? Can you confirm? Are you seeing this one, guys? For the midterm schedule, okay, I think I'm going to confirm na. So, yan, no? April 14, 15, 17, 18, 19. That's Friday, Saturday, Monday, Tuesday, and Wednesday. Now, class, I am supposed to give you an activity quiz, no? By next meeting for week 11 class. So, nataon na start na agad yun ng, ng midterm examination. Right? So, dapat ang meeting natin is on April 14 for week 11. Pero nagsisimula na ito ng exam. So, meaning, yung supposedly na quiz ninyo for midterm on April 14, magiging offset na lang yan on the finals. But basically, yun dapat ay yung content ng quiz is yung topic to be delivered today. And take note, yung topic today will be our last topic coverage for the midterm. Okay, so let us start sa ating discussion. Okay, kindly bring out your calculator. I'll be asking for your participation to this one. So, okay, ang topic for today is all about statically indeterminate structure, no, or statically indeterminate system, or system. No, so and after this topic, ang next is thermal stresses, which falls also under statically indeterminate case, no, for our structure. So ano ba itong, by the way, class, can I have a confirmation muna pala? No, I forgot. No, you are seeing my presentation here sa Paint tab. Anyone, can you confirm? The presentation is visible to you sa Paint tab.
Kita po, sir.
Okay, so now, when we say statically indeterminate problems or for system, kailan ba natin sinasabi yun? No? If you are my student last semester, I think you have an idea or I have discussed this one to you. No? When we say statically indeterminate, meaning the equilibrium condition, now the summation forces, horizontal, vertical, and summation moment equations are not sufficient in order for us to compute or to solve for the unknown forces in our structural system. So, ano ba yun, no? Meaning, hindi siya masasolve, no, by just those equation. So, let's have an illustration here. Let's say we have here a beam, no, with a pin support and a roller support at point A and B respectively. Now, kung ito ay may loading, no, so this is the loading, right? Then, kahit anong load yan, diba? Let's say 5 kilonewton per meter. Okay, with the dimension, right? With the equilibrium equations, no? Summation forces, summation moment, itong mga unknown forces, including the reaction. No? Of course, may reaction yan. Let's say AY yan, and BY for the vertical reaction at the support. Diba? By simply taking summation of moment at point A, you can solve for the unknown support reaction BY. And similarly, with the summation force vertical naman, then you can solve already for the unknown AY naman. Upon solving support reaction BY from the moment equation. Now, how about ito yung ating structure? Okay, let's say this is pin support at point A, then we have here what? Let's say we have a 2 rods here, no? Supporting also this particular beam or bar. Then, of course, meron yung binubuhat, no? Yung structure natin, let's say this is loaded with, let's say, 10 kilonewton. Okay? Then, kung mapapansin nyo class, no? Masasabi niyo ba na this is solvable already by simply using equilibrium condition? We need first, of course, to draw the free body diagram. Diba? If we will be cutting this one, no? So we will be cutting plane, makikita natin yung force acting internally at this rod. Let's say this is an aluminum rod, then this is steel rod. No? Yan ang mangyari with our free body diagram. Diba? if we will be drawing the free body diagram below, ito yun, no? 10 kilonewton load pa rin, then upon cutting plane, makikita natin yung force acting internally at the rod. No? This is, let's say, P aluminum, then this is P steel. Now, this is point A, of course, meron yung vertical reaction. Kung pin yan, supposedly may horizontal reaction. Diba? Diba? But take note, if you will be taking summation of horizontal, AX naman is zero since wala namang external force horizontally. Now, if we will be taking summation of moment, no, about point A, we will be having what? Two unknowns. Right? Meaning hindi siya solvable right away. And also, if we will be taking summation of force vertical, no, let's say meron tong distances, lagyan natin, or yes, let's say 2, then 1, no? Summation moment about point A equals 0, positive clockwise, then the equation will be what? Negative 3, P ng aluminum, minus 5, P steel, plus 10 multiplied by the moment arm 6 is equal to 0. Now, this is the first equation. But take note class, no? If you will be also, ang natitira lang natin na equilibrium condition is what? Summation force vertical and horizontal. With that, no, it leave us what? Summation force vertical equals 0 positive upward forces. That will be what? A1 plus P aluminum plus P steel minus 10 equals 0. Ano napapansin nyo class? We cannot still solve the problem by simply using equilibrium equation. Okay, summation moment and summation forces. Right? Meaning, this is what we call statically indeterminate structure. Okay? So, saan manggagaling yung other equations in order for us to solve this problem? Okay? So, kasi kung ito ay solvable under or by using equilibrium condition, then ito ay statically determinate. No? Since hindi siya ma-solve, indeterminate yan, no? Or indeterminate structure. So, ang other equation ay manggagaling sa ating compatibility equation. So, ano ba itong compatibility equation? Ito ay what? These are equation coming from the geometric relationship between deformation ng mga structure. Okay? Di ba, on our last topic, we have what? Discussion about deformation, no? Action deformation, no? Or yung elongation per unit. Strain is elongation of per unit length, or simply elongation is what? Yung direct formula, PLL over AE, but applying Hooke's law, no? For our proportional limit, right? So, doon magagaling yung ating third equilibrium or ating other equations, so coming from the compatibility equation. So ano mangyayari, no? On this illustration, let's say this is of course our illustration kanina, no? Saan magagaling yung compatibility equation? For this problem, no, of course, with this loading 10 kilonewton, ano may imagine nyo? At point A, di ba, this is what? Constrained or restrained to move horizontal and vertical. This is pin, right? Obviously. No, so ano mangyari? Itong bar na to will just rotate about point A. So meaning kung lulunduman yan, ganito yan, di ba? Okay? Exaggerated to. Okay? So mag-elongate itong rod, right? This will cause to elongate or this will tend to elongate. Then this is the elongation of aluminum and elongation ng steel. So from there, you can come up with a relationship or geometric relationship using what? Similar triangle. And magkakaroon tayo ng equation by means of deformation. And applying Hooke's law, elongation is what? PLL over AE. Then from there, we will be coming up to some equation wherein we will be using to compute for the unknown forces, including the support reaction. Okay, to further illustrate this one, of course, let's have an example. Prepare your calculator. Now, I'll be asking you to compute this one also. Though I will be solving this one, pero kailangan ko ng computation galing sa inyo to confirm my solution, okay, or my result. Now, ano ba yung general procedure? Okay, so that meron kayong guide or meron tayong guide. The procedure is that, of course, ang unang gagawin natin is to draw the free-body diagram, syempre, para makapag-derive tayo ng equation coming from equilibrium condition, di ba? Summation forces and summation moment. Ngayon, kung hindi sapat yun, to solve the unknown, including the support reaction, then it falls under what? Statically indeterminate structure. Okay? So meaning kailangan natin ng compatibility equation. So again, the compatibility equation will be coming from our deformation applying Hooke's law. And finally, use those equations available, the equilibrium and compatibility equation to solve for the unknown forces. Okay, so let's have our sample problem number one. Okay, um, okay, prepare your calculator once again. No, so 100% will do. Gawin natin 80. Masyadong maliit. 90. 25. Okay, 95 siguro. Para may-utilize natin yung solution. Okay, so let's solve this problem. Okay, anong tanong dito? The concrete post in figure A, this is figure A, no? Concrete post or poste or column is reinforced actually with four symmetrically placed steel bars. Okay, so ito yung cross-sectional area. If we will be cutting, if we will be producing cutting plane here, ito yung makikita ninyo. Okay, and upon introducing cutting plane, di ba, on our free body diagram, makikita natin yung mga internal forces acting on each member or material. Okay, so in this case, ang material natin is what? Meron tayong concrete. This is reinforced with four steel bars. No? Ang cross-sectional area ng steel bars, each is 900 millimeters square, given yan. No? So in total, that will be what? 4 times 900 millimeters square. Whereas for the concrete column, that is what? 300 by 300. So square lang naman yan. Solvable yung area. Now, we are to compute the stress in each material when the 100 kilonewton axial load is applied. So this is the point of application, no? Sa taas, 100 kilonewton and merong bearing plate. Okay? The modulus of elasticity are 200 gigapascal for steel and 14 gigapascal for concrete. So this is modulus of elasticity E. Okay, so plus if we will be solving for the stress experienced by the bearing plate, di ba? Force over area lang yan, di ba? Directly here. Pero we are to compute for the stresses acting internally sa ating column, di ba? Okay, so paano natin makikita yon? Di ba kailangan natin i-cut to in order for us na makita natin kung ano yung stresses occurring or internal forces occurring at the members or on our structure. So upon cutting plane, ito yung free body diagram, no? This is 100 kilonewton. Then, of course, representing the individual forces acting internally for concrete and steel. Nirepresent dito na ito ay P, column, no? Action force, P sub column, and P sub steel here. Take note class, yung force acting internally sa steel here, no, is represented already by a single force magnitude of P sub ST. Meaning, ang area natin to represent this particular force P sub ST is what? 4 times 900 millimeters square, or meaning apat na area yan. Kasi nirepresenta natin to sa single force already for all the forces here. Okay, may question? Go ahead. Question? Any question? If there's an attendance, later na lang yan. Okay, so now let's do the computation. So, summation, of course, anong una natin gagawin? Tingnan natin kung sufficient ba yung equilibrium equation. Okay, so equilibrium equation muna. Okay, so anong equilibrium equation na pwede dito? Diba? Summation of force vertical, pwede. Horizontal, hindi naman. Summation moment, hindi rin, no? We don't have a point where in zero moment yung mag-occur, no? So, summation of force vertical is equal to zero, positive, upward. So, upward forces are what? From the free body diagram, we have what? P sub steel. Take note class, represented na itong lahat ng force vertical for the steel as a single force, P sub ST, no? Plus P sub column or concrete rather, minus 1,000 kilonewton. But take note class, I want that our equations be in terms of a base unit of Newton and millimeter. So in this case, I have to multiply by 1,000 or times 10 raised to 3 in order for us na ito ay in terms of Newton, no? Yung base units. So equating this one to 0. This is what? our first equation. Okay, coming from the equilibrium condition or equation. Now, okay, thus, wala na tayong may makukuha equation pa. Now, from the equilibrium condition. Okay, meaning this is what? Statically indeterminate problem. Di ba? Hindi natin ma-solve siya by simply equilibrium condition. Okay, so we need the compatibility equation, but this will be coming from the geometric what? Deformation of our materials here, which are steel and concrete. So, saan magaling yan? Okay, di ba? We all know that upon applying 1,000 kilonewton load, di ba? This will, what? Magkakaroon ng elongation yung ating, or magkakaroon ng deformation yung ating um, column here. No? So we have concrete and steel, but obviously, no, kung yan ay magkakaroon ng elongation, what will happen? Okay, it will be shortened. No? So meaning, upon application ng 1,000 kilonewton load, sabay na magkakaroon ng shortening, no? In terms of elongation yung ating material, di ba? So, ma-shorten itong um, ating column, no? Itong steel and concrete. Okay, so meaning, kung ito originally, ito yung level here, no? Upon 1,000 kilonewton, by exaggeration, no? So meaning, ito yung magiging total elongation here, right, of our, but in this case, this is shortened, no? So meaning, ano yung relation that we can use, no? The elongation, okay, by the concrete is equal to what? The elongation by, yes, by elongation by the concrete material is equal to the elongation by what? Steel. Right? So, sabayan mag-shorten. Ngayon, last, by applying Hooke's law, di ba? Ano siya sabi sa Hooke's law? Di ba? Stress, applying Hooke's law. Di ba? At proportional limit, di ba? Ang sabi doon, stress is proportional to strain, but we have a constant of proportionality E, or the Young's modulus of elasticity for our materials, and given yan, no, sa ating problem. In each material, iba't iba yan ang modulus of elasticity. Okay? So, applying this one, di ba? You can recall that madederive natin yung elongation, what? PL all over AE. Right? Pero saan ba nanggaling yan? Di ba? Stress is equal to what? Modulus of elasticity multiplied by the strain. We all know that stress is force over area, which is P all over A. And what? Strain is what? Unit elongation per unit length. And obviously, manipulating this equation, no, by means of algebra, no, PL all over A ilalabas yan. Multiply this one, no, cross multiplication. Elongation is PL all over A. And in terms of stress naman, no, P all over A is stress. So, pwede rin yun na in terms of stress. Diba? Stress multiplied by L all over A. Okay? So, now, we are already what? We can already create another equation, no, from this what application ng Hooke's law, no, to our compatibility equation. Okay? So, anong ating pwedeng gawin? Di ba? Okay, we can use what? PL all over AE here, or itong elongation, stress multiplied by L all over E dito sa ating compatibility equation. Okay? Since ang hinahanap dito is in terms of stresses, no? So, ang gawin natin is that yung ating equation for the compatibility equation is in terms of stress. So, I'll be using this equation, no? So, elongation ng concrete is equal to what? Elongation ng steel. And ano yung ating pwedeng equate dito, di ba? So, i-equate natin yan. And we will be modifying the equation here in terms of this formula or equation. So, of course, elongation is what? Stress times length all over E. equals to stress times length all over E. But take note, these are for different materials. No? This is for concrete and this is for steel. So substituting our given parameters. No? Okay, so of course, this is for concrete on the left hand of the equation. Okay, stress ng concrete multiplied by the length ng concrete. By the way, class, kung mapapansin nyo, no? Di ba yung length here, the original length of the concrete is equal to the original length of the steel. Di ba? Isa lang naman yung length niyan, right? Nireinforce mo lang yung concrete with the steel. So, magka-cancel out dito yung unit length. So, matitira na lang sa atin is what? Stress ng concrete, okay, divided by what? E ng concrete, which is given naman dito, no? Modulus of elasticity of concrete is 14 gigapascal. Okay, I want this all these units in terms of Newton and millimeter. So, convert natin to into Newton per millimeter square or megapascal. So, we need to multiply it by 10 raised to 3. So, this is already in megapascal or Newton per millimeter square. So, is equal to, okay, on the right hand of the equation, stress ng steel divided by E ng steel. Take note, nag-cancel na yung net dyan. No? So, E ng steel or the modulus of elasticity ng steel is 200 times 10 raised to 3 megapascal. Kahit pala kasi hindi natin to convert na magka-cancel out lang naman yung unit. So, cancel yung megapascal, magka-cancel din yung 10 raised to 3. No? It will be cross multiplying. So, ang final equilibrium, compatibility equation is what? Stress experienced by the concrete is equal to cross multiply 14 all over 200 multiplied by the stress experienced by the steel. So this is the compatibility equation. So we write this one as equation number 2. Now, masasolve na ba yung ating problem? Masasolve na yan. Di ba? We have two equations here. We have two unknowns. So from here, di ba, isa-substitute lang natin ito sa ating equation number 1. But take note, di ba, we need the equation number 1 to be in terms of stress. No? So, from equation number 1, okay, for equation 1, di ba, we all know that stress is equal to force all over area, P all over A. So, meaning, force P is equal to what? In terms of stress, so stress multiplied by area. Okay, so we can use this expression, okay, or modify this equation number 1 in terms of stress. So P is stress times area. So in this case, for equation number 1, P sub steel is equals to stress ng steel multiplied by area ng steel. No? From equation 1, that will be P sub steel, no, is stress ng steel multiplied by area ng steel. Alam naman natin yung area ng steel, di ba? 4 na 900 millimeter square. Okay? Plus stress experienced by the concrete multiplied by the area ng concrete, and that's the force P, acting internally at the concrete. Okay, section, then minus 100, that's 1,000 pala, times 10 raised to 3 is equal to 0. Now, before we substitute this equation number 2 to this equation, lagay natin equation number 3 na lang to. Okay, compute mo natin yung mga areas. For area ng steel, of course, this is what? We have 4. 4 times 900 millimeter square. Ilan to, class? Apat na steel yan, reinforcement. So that will be what? 900 times 4. 3,600, millimeter square. For the area ng concrete, this is what? Square section yan. So that will be what? 300 by 300. No? So 300 times 300. But take note, class, we need the net area here. Ano yung net area? We need to less the area here ng steel. Right? In order for us to compute the net area ng concrete. So we will be lessing 4 apat na 900 millimeter square. Ilan to, class? Pakikompute ko to. Itong area ng concrete. Okay, I'll be solving, but I want this one coming from you. Pag may nakompute lang, sabihin, go ahead, paki-recite na agad. Ilan to? Kaya naman, paki-solve nito. Ilan yung nakompute ninyong area? Paki-recite, I cannot see the, ito ng mga nag-participate. Kindly speak, no, hindi ko siya makita sa screen ko. Pero parehas tayo na. Okay, sige, 86,400, that's correct. 86,400 millimeter square. Now, we have already areas, no, ng steel and concrete. Then, ano sunod? Don't be shy to recite, no? Go ahead. Just simply recite na para mabilis yung ating flow ng discussion. So, we are ready to use equation 3, no? In order to complete for the unknown stresses. So, for equation number 3, substitute lang natin lahat ng ano, substituting areas and equation 2 to 3. This is equation 2, no? So, stress ng steel multiplied by the area ng steel, that is what? Area ng steel is 3,600. Okay, take note ito yan. Pinipit natin kanina. Plus, from equation number 3, now, stress ng concrete, we need this one in terms of stress ng steel para solvable na yung stress ng steel, di ba? From equation number 2, stress ng concrete is 14 all over 200 multiplied by stress ng steel. So that is coming from our compatibility equation. Okay? So, right? Now, ito pa lang yun, no? Stress ng concrete in terms of stress ng steel. We need to multiply this one by the area ng concrete, which is solved by your 2 classmate, 86,400 millimeter square. And what's next? Minus 1,000 times 10 raised to 3 is equal to 0. Then, tapos paki-shift solve na lang to, no? Stress ng steel, pakilagay sa calculator, x na lang yan, no? Then shift solve. Okay, so, pakibigay agad sa akin ito. No? So, that will be stress ng steel, that's alpha x multiplied by 3,600 plus 14 all over 200 multiplied by alpha x times 86,400 minus 1,000 times 10 raised to 3. Ang unit natin, kung tatanungin niyo ako, since ang base unit is Newton in millimeters, so ang stress is Newton per millimeter square. And our answer, that will be megapascal. Ilan to? May nakompute na ako, but I want this coming from you. No? Go ahead. Kindly speak dun sa nagpa-participate na.
103.6848.
Yes, tama. 103. That's correct. Parehas tayo. 103.648, correct. No? Okay, let's make this official. Kapag walang instruction, yung computation natin and yung final answer is in 3 decimal places. So, correct yung answer na. Stress experienced by the steel is 103.648. Now, since meron tayong compatibility equation number 2, makakompute natin yung stress ng experienced by the concrete, di ba? Ituloy ko na lang na dito sa kabilang side. So, stress experienced by the concrete, di ba? From compatibility equation number 2 is what? 14 all over 200 ng stress experienced by the steel. So, stress ng concrete is 14 all over 200. So, dun sa nag-participate, i-multiply mo lang yung answer on your calculator by 14 divided by 200, di ba? Yan yung ating compatibility equation. Ilan to? Go ahead. Just recite. You are free to recite. Ilan to? Ilan yung na-compute?
7.255 po.
Okay. Correct. So, 7.2255 mega Pascal. Now, class, if the question is what is the force no, acting at the steel and concrete, di ba? I-multiply nyo lang itong, di ba? Stress is force over area. Di ba? So, force is what? Stress times area. So, ang pinapahanap is the force acting at the steel and concrete. Di ba? Multiply nyo lang itong stress sa area. And then that's already the force acting internally at the steel and concrete. Okay, so that's how we solve statically indeterminate problem. No? Draw the FBD. Kung mapapansin nyo, this is the pre-body diagram. Take the equilibrium equation. If this is not sufficient to solve the unknown, including the support reaction in the case na mayroong support reaction, and then proceed with compatibility equation. Okay, use the geometric relationship between the deformation no, ng ating materials, then apply Hooke's law. Okay, elongation is PL over AE, but this is coming from this relation that stress is proportional to strain at the proportional limit with constant of proportionality of Young's modulus of elasticity. Then, solvable na yung ating problem. So, let's proceed with sample problem number 2. Okay? Problem number 2. This can be, itong discussion natin can be finished by less than 2 hours. No? But I hope participate actively kung mabilis sa competition para mabilis yung flow ng ating discussion. Okay, so for sample problem number 2, let me read this question to you. Figure A shows a copper rod that is placed in an aluminum tube. Okay, this is the aluminum tube. Then, it is what? In between or napanggigitnaan ng aluminum tube. Okay, so the rod is 0.005 inches longer than the tube. Okay, so meaning itong copper natin here, copper rod at the center is mas mahaba ng 0.005. But the original length, no, or the length for the aluminum is 10. So meaning yung total length ng copper inside is what? 10.005, right, with this gap. So find the maximum safe load P that can be applied to the bearing plate using the following data. Again, ito yung bearing plate. Kumbaga, point of application lang yan ng ating load, no, kung ano man yung bubuhatin yan. No? So, represented by a single unit load P. So, ano daw yung kayang buhatin yan? No? What is the maximum safe load na kayang buhatin? Given na ang area ng ating mga materials dyan, okay, for the tube or rod is what? 2 inches for the copper and 3 inches square for the aluminum. This area and modulus of elasticity given then here for copper and aluminum, and also the allowable stresses. Take note class on our prelim topic, di ba? When we say allowable stress, this is also the working stress or yan yung maximum stress wherein yun lang yung kayang experience ng ating materials before it is what? Before yan ay mag-fail or masira. No? So meaning, i-limit natin yung ating stresses on these figures since allowable lang yan or the limiting stress. Okay? So, alam niyo naman, di ba? Stress is force over area. Then, we can come up with our solution with this one. Okay? So, again, anong unahin natin? Tingnan natin kung kaya ito ng equilibrium equation lang. Kung hindi kaya, then solve for compatibility equation. So, para makuha natin yung equilibrium equation, di ba, free body diagram naman lagi, no? FBD. So, in this case, if we will be cutting this one, no? Yung cutting section, ano makikita ninyo? Makikita natin yung internal forces acting internally both for the copper tube, copper rod, and also the aluminum tube. Okay? Again, represented here yung ating force acting at the aluminum tube with a single force. So meaning if we will be using area, yung total area na itong dalawa. Or in this case, binigay naman to yung total area sa table. Okay? And for the total area ng copper, 2 inches squared. So ito yung free body diagram. Now class, napapansin nyo, ba't ito ay nakalapat na bigla? Okay? Di ba upon application of load P, obviously, ito ay exaggerated class, 0.005. This is 1 inches. No, 0.005 is almost malit lang. No, this is already exaggerated by that means. And of course, if you will be analyzing that upon application upload, magkakaroon ng elongation between the member and it will come to a point wherein maglalapat din yung section na yan. But obviously, kung magkakat tayo ng um, cutting plane, makikita natin yung internal force acting internally with the materials natin or the member. So in this case, applying what? Equilibrium condition, equation, or equilibrium equation. Anong pwede? Di ba? Summation of force ulit. No? Equilibrium equation. Summation of force. Vertical is 0. Positive upward. So, upward forces are P aluminum plus P ng copper, PCU, minus the downward force P is equal to 0. And take note thus, since ang hinahanap naman dito ay yung maximum safe load P, so in terms of P na lang to on the left hand of the equation. So meaning the P or the safe load P is equal to the force acting internally at the aluminum plus force acting internally sa copper. So ito yung ating equation 1. And kailangan natin na-complete na itong internal force P acting at the aluminum and sa copper. Okay, considering na meron niyang mga allowable stresses. Okay? Or maximum or limiting stresses lang. Okay, paano ito solve? Wala naman na tayong ibang equations or equilibrium equations na pwedeng i-apply sa ating free body diagram. Diba? So, saan mga galing iba equation? Diba? From the compatibility equation. Compatibility equations. Okay? Sa analysis natin sa deformation ng ating material. Now, class, paano ba ito magde-deform itong ating materials? Diba? So, of course, ano mangyayari? No? What will happen? Okay, upon application ng load P, di ba definitely maglalapat yan. No? But obviously, kahit naman yan ay hindi siya compressive force at kahit pahila. No? Ano yung relationship na pwede nating makuha na between two materials or between elongation of two materials. Diba? Ano mangyari? Initially, may gap na tayo. No? Kung mapapansin nyo, meron tayong gap dito na 0.005 inches. Okay? And the elongation of the aluminum, which is the shorter member, plus 0.005 gap is simply equal to the elongation ng copper. Right? Kasi this is the copper tube. Right? So meaning, kahit yan ay compressive, no? Kung yan ay mag-shorten or mag-elongate, mag-equal yung what? Okay, the expression that we will be having is what? Yung equation is what? The elongation ng copper here is equal to the elongation ng aluminum plus the gap of 0.005. Diba? Kahit pahabain niya or paiksiin, depending on the force P, and direction. Diba? Yun yung ating compatibility equation. So meaning the elongation of copper is equal to the elongation of aluminum plus the gap of 0.005. Now class, I want all the equations in terms of inches and also sa force is pounds naman. No? So pounds and inches ko yung pounds and inches yung ating base units. No? So take note, that is very important when you are doing problem solving in this regard. No? Okay? Kasi pagka yan ay naglabo-labo na yung units ninyo, wala na nang sabog-sabog na yung result ninyo. No? You might be solving for super small values, no? Depending on the scenarios. So this is compatibility equation. But of course, we need to apply Hooke's law para magkaroon tayo ng relationship between elongation, forces, stresses, and modulus of elasticity. Right? Para we can relate equation 1 to our compatibility equation. So applying Hooke's law, pag nalimutan niyo pa to, iwan ko na lang. No? Again, stress is proportional to strain with the constant of proportionality of Young's modulus of elasticity. And we can derive that elongation is what? PL all over AE. Again, hindi ko na i-derive ito kasi galing lang din siya dito. Right? And in terms of stress, di ba? P all over A is stress. So, this can be simplified as stress multiplied by length all over E. So, ano yung gagamitin natin? No? Ito naman yung gamitin natin. Pwede naman ito. Pwede rin ito. It's all up to you. But our formulas here are in terms of P values. No? So, PL all over A na tayo. So, from compatibility equation here, converting that one into in terms of elongation PL all over AE, that will be what? PL all over AE. Okay, this is for copper, of course, is equal to PL all over AE. This is for aluminum, no? The elongation of aluminum. Plus, of course, the gap of 0.005 inches. And from this equation, pwede natin yung simplified na lang, no? I-substitute natin yung mga values here, no? The length and modulus of elasticity and areas para in terms of forces P na lang. And then, we can proceed solving already, no? For the unknowns later. But of course, we need to consider the allowable stresses of the material. So, now, from this equation, okay, that will be what? For the copper muna, no? P ng copper, of course, di pa natin alam yan. Multiplied by length ng copper. Ano yung length ng copper here? Okay, the length of the copper tube is what? 10, no? The original length, 10 plus 0.005. Okay, mas mahaba yan ng 0.005. So that will be 10 plus 0.005, that is 10.005. Take note, inches, no? Yung ating base unit. PL all over AE, the area is what? Ng copper, 2 inches square. So, hindi na tayo mag-convert. And E ng copper is what? 17 times 10 raised to 6 PSI, pounds per square inches. So, yan yung gusto nating base unit, di ba? Pounds and inches. No? So, this is 17 times 10 raised to 6. Okay? Ito pa lang yan, no? On the left-hand of the equation, equals to, for the aluminum naman, PL over AE. So, P ng aluminum multiplied by length ng aluminum. Again, ang original ng aluminum is 10 inches. So, 10 inches over area ng aluminum, which is 3 inches multiplied by E, 10 times 10 raised to 6. Okay? Of course, plus the gap of 0.005. Now, can we simplify this one? No? Ito muna, class. Itong left-hand of the equation. No? Itong constant. 10.005 divided 2 times 17 times 10 raised to 6. Nakibigay sa akin. No? So, 10.005 divided by 2 times 17 times 10 raised to 6. Go ahead. Sa nagko-compute, no? Just speak out already. Ilan to? Go ahead. Ito muna, itong constant ito. Okay, again, I cannot see the chat box, no? Kindly just speak, no? Go ahead, 2 point, ilan to? Itong constant na to. .005 divided 2 times 17 times 10 raised to 6. Anyone? I want this coming from you, no? Ilan to? Point. Pakicheck nga. Doon sa nag-compute, 2.943 times 10 raised to negative 7 P sub CU. Same lang. May nag-compute ba? Plus, pakicheck. .943 P sub CU. Okay. Plus, paki-solve nito, no? If none, I will not be asking your participation anymore. I'll be just proceeding with the computation. Okay, this is 2.943 times 10 raised to negative 7. P sub CU for the left hand of the equation. Then on the right hand of the equation, that is what? P aluminum. No? I-simplify natin itong equation na to. 10 all over 3 times 10, right? Times 10 raised to 6. Okay, on my calculator, this is 3.333. 3.333 times 10 raised to negative 7. P ng aluminum plus 0.005. But of course, I want this one to be mas simple na. So, i-divide ko both side by 2.943 times 10 raised to negative 7. Okay, dividing both side by 2.943 times 10 raised to negative 7. So, naging magka-cancel to. No? P sub C na lang yung nasa left hand of the equation. So, that will be what? Simplify natin. Okay, ito ay 3.333 times 10 raised to negative 7 divide 2.943 times 10 raised to negative 7. This is 1.13 P aluminum, of course, no? Plus 0.005 all over 2.943 times 10 raised to negative 7. Ilan to? Okay, on my calculator, now this is 16,989.467. Okay, so this is equation number 2 for our compatibility equation. Now, i-recta na ba natin itong isa-substitute dito in order to compute? No? Kung mapapansin ninyo, okay, masasabi na ba agad, no? From these two equation, di ba hindi naman kasi, ano, hindi siya masasabi. Kasi pag sinubstitute nito, two equations pa rin or two unknowns pa rin yung nandito, aluminum and P. So parang mag-equate lang yan sa ratio ng say flow P to our aluminum. We need to what? Use, no, or we need to consider itong allowable stresses. Okay? That we have for the copper and aluminum. Now, if we set, no, let's say we are to use, no, set natin, no? If the limiting stress is 20, this is KSI, no, which is 20,000. PSI, take note class, 1 kips is 1,000, no? 1 kips is 1,000 pounds. So, by simply multiplying by 1,000, that is what? KSI will be converted to PSI, no? So, 20 times 10 raised to 3 PSI yan, no? Itong PSI. So, that is 20 times 10 raised to 3 pounds per square inches. Okay, since 1 kips is 1,000 pounds. Now, if the limiting stress is 20,000 PSI, okay, for this is copper, then ano mangyayari, di ba? P is simply what? Stress times area. So kung limiting stress yan ng copper, then that will be what? P ng copper is equals to stress or the limiting stress ng copper multiplied by the area. Okay, that is what? Since meron tayong limiting stress na sinet dito, from the allowable stress, that will be at 20 times 10 raised to 3. This is pounds per inch squared, right? Multiplied by the area, which is 2 inches squared. Cancel yung inches squared. Obviously, pounds naman yung ating base unit. And yun yung gusto natin mangyari, that will be at 20 times 10 raised to 3 multiplied by 2. That is 40. No? 20 times 2, 40. Times 10 raised to 3 pounds. Now, if this is the limiting stress, ito yung ating value ng force for the copper. And let's check now. by using compatibility equation number 2, kung yung makompute natin na force ng aluminum will not exceed the limiting stress niya. No? So in this case, ang limiting stress ng aluminum is what? 10. Diba? So, check muna natin. No? So, substituting ECU is equal to 40 times 10 raised to 3 to equation number 2. Okay, tingnan natin kung ano yung value ng force ng aluminum. And i-check natin kung yun ay pasok sa limiting stress or allowable stress ng aluminum. So in that case, okay, using equation 2 here, so P sub Cu is 40 times 10 raised to 3. So 40 times 10 raised to 3 is equal to 1.133 P ng aluminum plus 16,989.467. Okay? So, solvable tong P ng aluminum. Okay? So, solve ko. Okay? 40 times 10 raised to 3 is equal to 1.133 times x plus 16,989.467. Keep solve. That is 20,309.385 pounds. Now, are we using this one already? No, itong values ng copper and aluminum forces to our equation number 1 to finally solve for the safe load P. Bago yon is i-check muna natin kung itong mga value na to ay will not be exceeding the allowable stresses. For the P sub Cu here, ng copper, alam natin hindi yan mag-exceed, di ba? Kasi sinet natin as the limiting stress itong 20 KSI for the copper, di ba? Using the allowable stress. So, we all know hindi ito mag-exceed. But for the aluminum, no, hindi natin alam. Para natin malalaman yun, di ba? Complete natin yung stress. So, that will be stress na experienced by the aluminum material equal to P ng aluminum divided by area ng aluminum. Right? That is what? 20,309.385 pounds divided by area ng aluminum. Ano yung area ng aluminum? Diba? That is what? 3 inches square. So, 3 inches square, 3 inches square. So, again, this is in terms of PSI. So, 2309.305 divided by 3 inches square, it will give us 6,769.795 pounds per square inches or PSI, or in terms of KSI, diba? Divide 1,000 lang natin. That will be 6.7 697, that is 77 KSI. So check natin kung ito ay hindi exceeding sa allowable stress. Okay, 10 KSI yung ating allowable stress for aluminum. So meaning, kuha na agad, no? So we will be using P sub Cu and P aluminum, no? Itong values na to in order to compute for the safe load P. Okay? So kumbaga ito yung isa-set natin na bubuhatin or i-carry ng copper and aluminum. Okay, this is less than 10 KSI. So, check. No? Now, with that, no, i-add natin. No? So, first, substituting values of P sub Cu and P aluminum to equation number 1 from the equilibrium equation, diba ito yun? The safe load P. Okay, i-zoom ko na lang here since ito naman ay patapos na sa ating solution sa problem number 2, which is P aluminum plus P ng copper. So the safe load P is what? The value ng force ng aluminum here is what? Or force acting internally sa aluminum, this is 20,309.85 plus this is 40,000, no? 40 times 10 raised to 3 pounds. So this is in total, ilan to? 60,309.385 385 pounds. Or in terms of kips, no, that will be what? One kips is 1,000 pounds, so divide by 1,000 lang. No? This is what? 60.309 kips. Okay, so this is the safe load value of P. Okay, kung mapapansin nyo, ang naging hatian is what? No? For the aluminum and copper in the binubuhat yan. Now, mas if halimbawa, no, you set the limiting stress, ang reference mo muna initially is yung sa aluminum na 10 KSI, then ano mangyari? You'll be solving for a value of magnitude of force P for the aluminum, setting this as the stress. Ngayon, class, if you will be solving, no, actually, sinod namin yung kahapon sa ibang kabilang section, lalabas na masolve yung value ng pinang aluminum, no, or pinang steel is sosobra yon, no, sa rather sa copper, no. Sosobra yon sa allowable stress. So in that case, hindi mangyayari na ang set mong limiting stress is for the aluminum kasi may exceed ng copper yung kanyang allowable stress. So bumalik kami dun sa computation na ang naging limiting stress is for the allowable stress ng copper. And then eventually, we have solved that the aluminum, no, um, that limiting stress is for the copper, then safe naman yung or less than yung allowable stress. Okay, or less than the allowable stress yung computed aluminum force P here. No? So ito yun. This is what I have shown you sa ating solution. Then use a compatibility equation again uh, to what? Um, to finally solve to aid the equilibrium equation to solve the unknown. Okay, so for example, problem number 3, let me just open the solution sheet since there's no one participating already to, to our discussion. No? Discuss ko na lang yung solution. Okay, let's wait here for the moment. I'll just thoroughly discuss na lang yung mga solution sa ating presentation. Okay, let's wait. Don't worry, I'll be sending a PDF presentation to you, no, for the solution. Okay, let's proceed, no, for example, problem number 3. Okay, so for problem number 3, figure A shows a rigid bar that is supported by a pin at A and two rods, one made of steel and the other of bronze. Okay, neglecting the weight of the bar, compute the stress in each rod caused by the 50 kilonewton load using the following data. Okay, so these are the figure, no? Ito yung original figure. So this is our structure. We have a bar here, no? Pin supported at point A, and we have vertical rod hangers here for steel and bronze. 1.0 meter length na steel hanger and bronze 2 meter. Then this is the dimension for our bar. Meron tayong load na 50 kilonewton acting at the end. Now, these are the other properties for our material for the rod. For the steel rod, 600 millimeter yung area. Then for the bronze, 300 millimeter square. For the bronze, then the modulus of elasticity are here also. No, ito yung data. Now, again, we will be checking kung sufficient ba yung equilibrium condition. Kung hindi, then that is statically indeterminate. Then we will be using compatibility equation to finally solve the problem in that case. Okay, so we need free body diagram, of course. By introducing cutting plane here, ano mangyayari? You will be seeing the force acting internally sa steel and bronze. So, represented here by a free body diagram, that's P sub ST and P sub bronze. Okay, for those forces. And of course, to represent the reactions acting at support A for the pin, diba, meron yung horizontal and vertical reaction. But obviously, if we will be doing summation of force horizontal, wala naman tayong external force acting horizontally sa ating structural system here. So AX is here obviously. For AY, so we can solve it. Summation of force vertical, but obviously those were three unknowns here. And summation of moment at point A, ano mangyayari? Magkakaroon tayo ng two unknowns pa rin. Okay? So meaning the equilibrium condition, okay, or the equilibrium equation is not sufficient to solve this problem. So this is a statically indeterminate structure. Okay? So again, kailangan natin ng equilibrium equation, summation moment at point A, okay? From the free body diagram, summation moment at point A. So, itong forces ng steel and bronze will rotate about point A, no? Yung ating reference point for the moment, counterclockwise, and that is negative for our sign convention. Then, itong 50 kilonewton will rotate about clockwise, no? At point A. So, or will rotate clockwise at point A, no? About point A. So, meaning positive to. So, in our solution, mapapansin nyo, negative 0.6. Why is that? So, meron tayong multiplier ng 10 raised to 3. I want all the units here na in terms of millimeters. So, that is why may multiplier tayo ng 1,000 or times 10 raised to 3 since 1 meter is 1,000 millimeter. Okay, so yun yung moment R multiplied by the force P sub ST. Similarly with bronze and the 50 kilonewton force. No? These are the moment arm here with a multiplier of 1,000 para maging millimeter. Equals 0. This is the first equation for our equilibrium equation. Now, for the compatibility equation, since this is not sufficient to solve the problem for the statically indeterminate structure, so we need the geometric relationship using what? No? From the deformation ng ating structural system. So in this case, for at point A, pinyan, di ba, this is restrained or constrained to move horizontally and vertically. So meaning hindi yan mag-move. From figure C here, this is the original level position or the original horizontal level. No? So meaning kung naka-pin support at point A, ano mangyayari is that mag-rotate lang itong bar about point A. So magdulong-dulang yan dito, no? Yung ganyan. By exaggeration, ano mangyayari? No? Naka-fix pa rin at point A, no? Pero ito na yun, no? Itong hidden line represents the final position, no? Of this horizontal bar, okay, initially after the load 50 kilonewton is applied. Kasi nga ano mangyayari, by exaggeration, no, itong steel and bronze ay magkakaroon ng elongation after that load is applied. Okay, so ito yung representation here, no, the elongation ng steel and bronze. Then, saan magagaling yung ating compatibility equation? So, by using similar triangle, no? The first triangle here is what? Since yan ay 90-degree triangle or right triangle, then we can use what similar triangle theorem or property, di ba? Itong smaller triangle na to can be what? This is similar to the big triangle here. So we can simply say what? We can use the relation from each side, no? So that will be what? Elongation ng steel is all over 0.6 is equal to elongation ng bronze all over. Of course, this is the side ng bigger triangle, which is 1 plus 0.6. That is why 1.6 yan. Okay? So, those were sides of the similar triangle. Now, applying Hooke's law, stress is proportional to strain. Then we can come up solving elongation is PL over EE. Or in terms of stress times length all over E. Okay? So, and in this case, ano nangyayari? Now, you can come up solving for this relation, no? Okay, paano ba yan? Diba? This is what? Elongation ng steel, no? Multiply lang natin ito, cross multiply. So, meaning elongation ng steel is equal to 0.6 all over 1.6 ng elongation ng bronze. So, this is the relation. Then, substituting this expression, no? Elongation PL all over A sa ating equation, then that will be PL all over A ng steel is equal to 0.6 all over 1.6 multiplied by the elongation of bronze in terms of the equation PL all over AE, that is for bronze. Then, let's substitute all the given parameters. So, we have the length naman ng steel rod, length ng bronze, then individual modulus of elasticities and area. And we can come up here, no? So, ito yun, no? PLL over AE is equal to 0.6 over 1.6 PLL over AE ng bronze. Substitute lang natin yung mga um, given parameters, no? Yung length ng ating steel rod is what? 1. That is why 1,000 yan. And base unit is millimeter and newton. Take note. So, PLL over AE per bronze, 2 meter yung length ng sa bronze, 2,000 yan. Then, PLL over AE, area ng bronze, rather steel to, no? So, steel is 600 millimeter square. So, nothing to convert. Then, multiplied by 200. Take note, this is in gigapascal. That is why may multiplier tayo ng 10 raised to 3 para maging megapascal for the base unit of Newton per millimeter square. Okay? So, parehas lang din. Dun sa right hand of the equation. Substitute lang natin yung parameters ng bronze and you will be coming up to a simplified equation here or relation between force acting at the steel internally and the bronze, which is 3.615 P ng bronze. Okay, so galing yan. Dito lang din yan, no? So, pag-solve nyo, i-simplify lang natin yung mga constant. Okay? Then, yan na yung final relationship sa ating compatibility equation. In this case, this is equation number 2. So, anong gagawin natin, di ba? I-substitute lang natin to equation 2 to equation number 1 here, no? From the equilibrium condition. So, as you can see, this is equation number 1, no? 0.6 times 10 raised to 3 P sub steel, and we have a relation of P sub steel is equal to 3.615 P ng bronze, no? And substitute natin to sa equation 1. Ito yung makikita nyo dito, no? 3.615 P ng bronze minus 1.6 times 10 raised to 3 P sub BR here plus 50 times 10 raised to 3 multiplied by 2.4 times 10 raised to 3 is equal to 0. And yung equation natin is in terms of parameter na P sub BR or force acting internally sa bronze. Then, solvable na yung P sub BR here, di ba? From this equation already. And eventually, solvable na yung P sub ST from the compatibility equation, right? Which is equal to 3.615 ng imputed P sub bronze, no? Or PBR here. So, these are the forces already acting internally. And ang hinahanap is what? Okay? Is the stress on each rod. Since computed na yung forces acting internally sa bawat rod, divide lang natin yun sa area, then that's already the stress experienced by the material or the member sa structure natin. So, force over area will come up to compute stresses here for our final answer. Okay, so now we move forward. Okay, I'll be sending this one to you. I'll not be asking some participation or yet. No, I think I'll just be discussing this one to you. No? Can I just have a confirmation? If are you with me with this last topic already? For thermal stress, can you see?
Yes po.
Yes po.
Okay, so now class, as I have told you before, di ba, yung elongation is coming from what? Okay, it could be from its own weight or also it could be coming from the load applied, no? So mag-elongate yan or magkakaroon ng deformation yung ating mga material sa ating structure. But also, di ba, pagka nagkaroon ng temperature changes, di ba? Okay, particularly sa steel, no? Kapag ka mainit, no, or nagkaroon ng change in temperature, mas uminit, nag-elongate yung ating materials. Pagka lumamig, nagko-contract or in that case, umiiksi, no? And in deformation actually is not only linear. This is isotropic, meaning in all direction, di ba? Pag nag-compress siya, nag-contract, even yung area, hindi na naman lumiliit, no? Yung area is what? Lumalaki din in that manner. But we treat the linear deformation here in terms of taking into account yung ating deformation or elongation. Okay, so paano natin tinatake into consideration yung temperature change? Siyempre, di ba, nagkaroon ng contraction, di ba, mas diliit, okay, temperature change, magkakaroon ng stresses internally sa ating member since nagkaroon ng contraction or elongation. Okay? So in that case, ang tawag dun sa stress na yon is what we call thermal stress. Okay? And also, elongation then due to uh, thermal change when we take into account yung elongation. So, ang ginagawa natin is that nilalagyan lang natin ng abbreviation here, sub T, sa bawat equation natin. Okay? So, our formula, in order to consider the temperature change, take note guys, di ba, ang ating um, strain formula is what? Unit elongation per unit length. And if we take into account yung strain produced due to temperature change, ang ginagawa natin, nalagyan natin ng abbreviation na SUMT here to denote that the strain is produced by the temperature change. Okay? So, and the stress is produced internally, no? Is what we call thermal stress. Now, the formula here is what? For the strain due to temperature change is equal to, we have alpha multiplied by the delta T. And delta T denotes change in temperature. No? So, of course, yung bawat material, by the way, meron niyang tinatawag na workable temperature, but in that temperature, in that original temperature, hindi magkakaroon ng thermal stresses or hindi magkakaroon kung mas tumaas or mas bumaba, doon na mag-occur yung ating um, thermal stresses. So this is the formula to take into account. That is alpha multiplied by delta T. Alpha here is what we call the coefficient of thermal expansion. And ang unit niyan is per degree Fahrenheit or per degree Celsius. Meaning, di ba, ang delta natin here is in terms of course, what? Temperature unit, di ba? So meaning, this is, in each material, meron niyang elongation per, what? Or the value ng strain ay nakarate yan, no? In terms kung ilan man yung change ng temperature. Okay? So, this is actually coming from some test results sa lab, no? Sa steel, sa aluminum, no? Tinest na nila yan. Okay? Kung ano yung coefficient of thermal expansion. Typically given to no, sa mga problem. Now, positive delta T produces positive strain, meaning elongation, and negative delta T or negative change in temperature will produce negative strain or contraction. Diba sa ating elongation, positive for elongation and negative din for pag-i-exceed with our sign convention. Okay, so now kung ito yung strain, di ba, elongation can be computed with what? Elongation due to temperature is simply strain due to temperature multiplied by the original length. And that's the total elongation already. So ito yung makikita nyo sa equation na to. Okay, since alam naman natin yung formula ng strain, some T here due to temperature, di ba? Alpha delta T lang yan multiplied by the length, and that's already the unit elongation due to temperature. So, typically, ang aming dito, ang aming mnemonics is alat, no? Kasi A alpha L delta T, no? Alat, pero alpha delta T times length yan, no? For our elongation for due to temperature. So again, what is our procedure here for our computation? Ang procedure here is that of course, kung hindi sapat yung equilibrium condition, no, then we will be using compatibility equation. But most problem dealing with thermal stresses, no, and statically indeterminate yun. So, meaning kailangan natin ng compatibility equation lagi. Okay? So, in that case, kung yan ay statically indeterminate, ito yung procedure. No? Ang ginagawa is that we are removing the constraint or the support restriction, no? So that yung prevention ng elongation or contraction ay mag-visualize natin due to thermal deformation, no? So meaning class, di ba kung tatanggalin natin yung support, di ba? The bar or the member is free to to elongate or to shorten, no? So this procedure is sometimes we refer to as the relaxing the support, no? So in that case, kailangan nating mag-draw ng deformation, no? So, no, in an exaggerated scale after ma-remove natin yung constraint. And then, um, we apply a single force P, action force P, in order to what? Since nirelax natin yun, ibabalik natin yun sa original constraint at the support. So in that case, the deformation is already due to applied load P, no? And kumbaga, babalik yun sa original position. In that case kasi class, kumbaga parang in this method, di ba, after certain change ng temperature, di ba, pag bumalik naman yun sa original um, working temperature, right, babalik yan sa original length. Definitely, di ba? So, yun yung method wherein we introduce the force P acting at the member, no, in order to what finally bring back um, our system on its original condition. So this will be illustrated sa ating sample problem, no, para mas ma-visualize ninyo. Okay, so for sample problem number 1, okay, we have here the horizontal steel rod 2.5 meter long and 1,200 millimeter square in cross-sectional area. It is secured between two walls as shown in figure A. So this is figure A. Again, this is the wall support, no, for this rod. Okay, so length of 2.5 and cross-sectional area of 1,200 millimeter square. Now, if the rod is stress-free, no, meaning this is the working temperature, 20 degrees Celsius. So wala yung stress at 20 degrees Celsius. Compute the stress when the temperature has dropped to negative 20 degree Celsius. Meaning as nagkaroon ng temperature change. So, once nagkaroon ng temperature change, ano mangyayari? Diba? Magkakaroon tayo ng thermal stress and strain, okay, sa ating material. So, ano yung delta T or change in temperature, di ba? Final minus initial temperature, that will be what? The final temperature is negative 20 minus the initial temperature of 20 degrees Celsius. So ito yon. So negative 20 minus 20, that's negative 40 degrees Celsius for the change in temperature. Negative change meaning what? Magkakaroon ng contraction or EXA yung ating material for our steel. No? Material. So in this case, ano mangyari? Di ba, ang method is that i-relax natin yung system. Di ba? Pag sinabi natin i-relax, no? Magtatanggal tayo ng isang support here. No? It could be itong left support, no? Itong wall support sa left or right. But on this solution, ito ay yung right. Now, if we relax this support, no, if we remove the constraint here or the restraint, ano mangyayari? Since contraction yan, negative yung change in temperature, magko-contract. No? Kung tinanggal natin to, i-exaggerate natin, di ba? Kung mag-contract, i-exe, di ba? So, upon umixia, no, upon releasing the support here, this is the elongation due to temperature at this point, exaggerated. Now, para mabalik natin to sa original condition at this vertical line, we need to introduce the force P here. No? Kumbaga, hahatakin yan pabalik sa ating original condition. No? And that particular elongation will be caused by applied to P. No? So this is what? Ang formula is what? PL over E. Okay, I think I'm disconnect ako, no, with the. Okay, let me continue. Patapos na rin tayo with our discussion. Okay, now let's proceed. Now, so, saan ako naputol, class? Can I check? Saan ako naputol na area here? Dito ba or isang discussion ako naputol?
Sa P pa lang po.
Sa P? Okay. So, For P here, now again, di ba, this force P will bring back no, this particular rod into its original position. Okay? So, in this case, anong relationship that we can have for our compatibility equation? Di ba? The elongation due to temperature is equal to the elongation due to internal force P experienced by the rod since magkakaroon ng internal stress. Di ba? So, um, from here, ito yun, no? This is elongation due to temperature is equal to elongation due to force P. So, alam naman natin kasi ang formula is what? Due to force P, that is PL all over AE, or in terms of stress, diba? Stress times length all over E, since P all over A is stress. Okay, and elongation due to temperature is what? Alat or alpha delta T, alpha delta T times length. No? So, equating both this equation, no? Substituting these formulas, then we'll be coming up what? Okay, this is what elongation due to temperature. Okay, iba na pala yung arrangement dito, pero ito naman yung galing dito, yun, no? Elongation due to force P is equal to elongation due to temperature. So, stress times length all over E is equal to alpha, delta T, and L. Okay, this is the second equation. Now, substituting the given parameters, but obviously, ang hinahanap dito class ay ano. Okay, ang assumption is that what? Okay, the walls will not move or rigid. No? In that case, we relax the support, and ang hinahanap is I think the stress. Tama ba? Compute for the stress. So, from this equation here, no, this can be simplified to what? Okay, isulat ko na lang dito. No? This is stress times length all over E is equal to alpha delta T times length. So, stress yung hinahanap. Take note class. Original lengths are what equal naman. That will be cancelled. So, the stress is equal to what? Alpha delta T multiplied by T. And that is what you will be seeing on this equation. Now, class, ang kulang lang sa solution here ng on your module is that what? Okay? Yung sign ng ating change in temperature, it should be indicated here na may negative sign, no? Kasi this indicates that this is what? A compressive stress. Okay? But in this case, nilagay ko na lang dito na ginamit ko na lang na compressive stress yan. Kasi nga, di ba, that will contract with the change in temperature no, na negative. Okay? So, magkakaroon ng contraction or EXA yung ating rod. Okay? Now, that is for part 1 wherein the wall is rigid or it will not move. No? So, how about yung halimbawang the wall is not rigid enough to hold the rod no, pag nagkaroon ng change in temperature. So, sinabi dito na the wall moves together at a distance delta of 0.5 millimeter. So, meaning, sabay silang mag-move. No? Yung wall no, kapag nagkaroon ng deformation or elongation. So, for part 2, ano lang yun, ganun pa rin naman yung treatment. No? I-release natin itong isang support. But in this case, since this is not rigid enough, nagkaroon ng elongation no? For our what? Nag-move yung ating wall. So, this represents already delta, yung iminove ng wall. No? So, in this case, the elongation due to temperature is equal to what? The elongation due to force P plus the movement ng wall. Okay, meaning class, since nagkaroon, hindi masyadong rigid yung wall, di ba? Hindi ganoon kalaki yung magiging magnitude ng internal stresses. And in that case, yung force P for the rod, no? Para maibalik yan sa restraint na yan. Okay, so kumbaga, di ba, kung mapansin niyo kung fixed talaga yan, di ba, mas malaki yung stress na nakaramdaman niya kasi rigid na rigid. Pero kung ay medyo hindi rigid, di ba? Okay, with the effect ng change in temperature, kung hindi gumagalaw, di ba? Hindi ganun ka-stress yung ating rod here and you are expecting a lesser value of magnitude ng stress compared dun sa nauna kanina. So, ano nangyari sa equation? The compatibility equation, nagkaroon lang tayo ng additional delta here on our right hand of the equation. Okay? And again, the similar formula naman. Elongation due to temperature, elongation due to force P, okay, plus delta, then substitute all the given, okay, and you will be coming up to solve uh, the stress value here experienced by the rod internally if the wall is not rigid enough. No, 53.6 megapascal compared to the value of 93.6. No? Obviously, mas malaki to kasi nga rigid yung wall. Hindi gagalaw, di ba? Kahit magkaroon ng, kumbaga, persado itong ating rod. Okay? Whereas kung hindi rigid, since kumalaw, hindi masyadong persado yung rod internally. No? Baba yung stress. Okay, so that's for sample problem number 1. For sample problem number 2, okay, this is the last example problem kasi itong sample problem number 3. Ito ay parang supplemental problem lang. 2 and that's up for you to review that particular solution. No? So, sample problem number 2. Okay, so what do we have here? We have, okay, basahin ko yung problem, pero kahit with this given figure, no, alam na natin yung ano yan. Okay, kung anong klase structure yan, ano yung condition, di ba? So for figure A, shows a homogeneous rigid block weighing 12 kips that is supported by 3 symmetrically placed rod. Okay, so meaning symmetrically equal spacing yung meron dyan. Okay, the lower ends of the rods were at the same level before the block was attached. So the lower ends of all rods level daw yan bago i-attach itong 12 kips na slab or weight or block. Okay, so determine the stress in each rod after the block is attached and the temperature of all the bars increased by 100 degree Fahrenheit. Use the following data here. So the data available are area, modulus of elasticity E, and alpha or the coefficient of thermal expansion here. Now class, kung mapapansin nyo, no, ang elongation will be coming from what? Okay. Of course, with the weight here, magkakaroon tayo ng elongation on each rod due to the force experienced internally by the steel and bronze rod. So meaning we have elongation due to force P, axial load P, which is PL over E. And the second elongation will be coming from what? Since magkakaroon ng temperature change, meron tayong elongation due to temperature also. Okay? And due to self-weight, meron ba? Wala namang binigay dito na parameter. So simply we are to neglect yung elongation due to its own weight ng mga rod. Okay? And what else? Wala naman ah. So, by using equilibrium condition, di ba? If we will be introducing a cutting plane here, summation force vertical, this is 12 kips, di ba? If you will be drawing a rebar diagram, then ito yan, right? P steel, P bronze, and P steel and 12 kips. Summation force vertical, that's an equation. Right? So, hindi yun sufficient in order to solve this unknown. So, we need compatibility equation from our geometric relationship sa mga deformation. Okay? And dalawa yung deformation due to temperature and due to internal force axial load acting at each rod. So, this is the p-valley diagram, no? If we will be applying equilibrium condition, ito yung binabanggit ko kanina. And this is the diagram we're in representing yung geometric relationship between the deformation or elongation ng materials here. So in this case, class, original level is what? Horizontal. Upon application ng 12 kips, di ba? Lulundo itong ating mga material. So mayroon tayong total elongation in each material na elongation due to force P and also the elongation due to temperature. So meaning class, kung mapapansin ninyo, equal lang naman yung total elongation here. But take note, we have two elongation. So on our formula, that will be what? Ito na yan. Ito. The elongation ng steel and bronze is equal, but we have two elongations here caused by changing temperature and caused by the force P acting internally sa mga rod. Okay, so from this equation, no, applying Hooke's law and also using the formula for elongation ng temperature change, which is alpha delta T times length, then we can come up with the second equation here na alpha delta TL, that's for steel, then PLL over AE for the elongation due to the force P. And similarly sa right hand of the equation, yun din yung makikita natin na equation. Then substitute all the given, di ba? Given yung area, given yung E, given yung alpha, okay? Given yung length, nandun naman yung length, and you will be coming up with this simplification ng equation wherein the equation will be in terms of value ng P, no? P steel and P bronze. So magkakaroon tayo ng final relationship or equation, no, for the compatibility equation. Ito, lagay natin third equation na lang, no, for the call out. So from here, no, we will be using this compatibility equation to solve for the unknown sa other equation coming from the equilibrium analysis or equilibrium condition. Summation force vertical, di ba? That will be what? Dalawang P sub ST plus isang P, no, ng bronze, or 2P ST plus PBR is equal to 12 kips. Okay? So, summation force vertical lang yan. And substitute natin tong equation 3 to equation from the equilibrium condition, then solvable yung force acting internally sa steel and force acting internally sa bronze. Now, ano hinanap dito? Hinanap ba yung stresses? Kung hinanap yung stresses, then i-divide lang natin itong computed internal force acting at the rods sa kanilang individual area, then that's already the stress, di ba? P all over area lang yan. So, ito yon. Now, if you have computed positive or negative values ng magnitude ng forces, di ba? Positive is for tension and negative is for compression in our assumption. So, meaning, okay, if you'll be indicating tension and compression, then yun lang naman yung pag-take into account. No? So, on the solution here, nag-negative yung value ng computed force acting at the bronze and for the steel positive. So, meaning tension and compression for the force acting at the bronze here. No? So, what else? Meron pa ba ditong i-discuss? So, I think wala naman na, no? I-review na lang tong problem number 3. Okay? So, the solution here naman ay given. So, this is just a supplemental problem. On this sample problem number 2, okay, I'll be sending to you the PDF here for this presentation. Okay? So, do you have any question or clarification with the topic? No, I would much appreciate if you have question to clarify. No? Yes. Okay, may question ba or clarification before we dismiss the class after you checking your attendance? No? May question?
Wala po.
Okay, so say present if you are here already. Bautista. Cuevas.
Cuevas, sir, present po.
Gante.
Present po.
Gonzales. Marcos pala. No? Marcos. Mateo Saavedra. Mateo is also present. Saavedra, Sumampong.
Present po, Sumampong.
Okay, so that means absent today is Saavedra, Marcos, and Bautista. Okay, so that's it for today. We are done. Good luck on your preparation sa midterm examination.